Good evening, children.
Good evening.
Good
Good
evening.
evening, ma'am.
Good
Good
evening,
evening,
ma'am.
children. Hi,
Good
children.
evening.
Good evening. Good evening. Somebody's mic is enabled. Disable your mic. So much you have already seen in 9th standard. Just read this and then I'll take you to the next slide. So probability is a numerical measure of uncertainty. Probability of an impossible event is 0. Probability of a sure event or a certain event, is 1. All of the probabilities lie in the range 0, less than or equal to P of E is less than or equal to 1, where P of E is the probability of the happening of the event E. Okay. So this is all about 9th standard. Yeah. So now, okay. So now let's discuss the outcomes when a coin is tossed. Okay, so you have a coin with you, a 1 rupee coin, a 2 rupee coin, whatever, you have a coin with you. You have an Indian coin, okay? You have an Indian coin with you and you toss it up once. You toss the coin once. So the outcomes, when you toss a coin once, the outcomes are heads and tails. Either the coin will show up heads or it will show up tails. Now, supposing you toss the coin 2 times, okay? Toss the coin 2 times. Toss the coin 2 times. See, tossing one coin 2 times is the same as tossing 2 coins once. See, why you are tossing one coin 2 times? Because you have only one coin with you. You have only one coin. So you toss it 2 times, once, twice. Once you'll toss it, you'll note the outcome. Again, you'll toss it, note the outcome. But supposing you have 2 coins with you. So both the coins, you'll toss it up simultaneously. You'll toss both the coins simultaneously. And you will see the outcome on one coin and the other coin. Tossing one coin 2 times is the same as tossing 2 coins once. So when you toss the coin 2 times or toss 2 coins once, it's the same. Both are the same. So the outcomes here will be write out that HT 2 times. Write out that HT 2 times because 2 times you're tossing, right? So write out that 2 times. HT and write H for the first one and T for the second one. So HH, HT, TH, TT are the outcomes. The outcomes when you toss 2 coins once or 1 coin 2 times, the outcomes will be HH, HT, TH, TT. What do we understand by this? The first coin shows heads. The second coin also shows heads. The first coin heads, second coin tails. First coin tails, second coin head. Both the coins tails. Now, supposing you toss 3 coins. 3 coins once or 1 coin 3 times. Both are the same. 3 times. Both are the same. Supposing you have 3 coins with you. You toss all the 3 coins simultaneously only once. Or if you have only 1 coin with you, you'll toss that 1 coin 3 times. The outcomes are the same in both the cases. So for this, write out these outcomes 2 times. HH, HT, TH, TT. HH, HT, TH, TT. Write it out 2 times and fix H for the first row and T for the second row. So these are the outcomes. These are the outcomes when you toss 1 coin 3 times or 3 coins once. So you understand, this is on the first coin, second coin, third coin. If you have 3 coins, if you have only 1 coin, this is in the first toss. This is on the second toss. This is on the third toss. First, if you have only 1 coin, first toss, second toss, third toss. If you have 3 coins, then this is on the first coin, second coin, third coin. Okay. So let me write it once again neatly. 1 coin, okay, you toss. If you toss 1 coin, if you toss 1 coin, that means only once. The outcomes are or it's also called the sample space. It's also called the sample space. Okay, HT. That coin can show up either heads or tails. Okay. The next one is tossing a coin 2 times. 2 times or tossing 2 coins once. Okay, so the outcomes here. The outcomes are the sample space. Outcomes or sample space. I said write the earlier outcomes 2 times. H, T, H, T. The earlier outcome, write it 2 times. H, T, H, T. Fix H for the first row, T for the second row. So these are the 4 outcomes. So in the first case, we have 2 outcomes. We have 2 outcomes in the first one. In the second one, we have 4 outcomes. 4 outcomes. HH, HT, TH, TT. Now tossing a coin 3 times, or tossing 3 coins once. So what are the earlier outcomes you have? HH, HT, TH, TT. Write it 2 times. HH, HT, TH, TT. And fix H to all the outcomes in the first row and fix T to all the outcomes in the second row. So these are the outcomes when you toss 1 coin 3 times or 3 coins once. Or these are this is the sample space. What you see is a sample space on performing the experiments. So when you toss a coin once, 2 outcomes. When you toss 2 coins once or 1 coin 2 times, 4 outcomes. When you toss 3 coins once or 1 coin 3 times, 8 outcomes. 8 outcomes. So it's basically 2 to the power 1. This one is 2 to the power 1, 2 outcomes. This one is 2 squared, 4 outcomes. This is 2 cubed, 8 outcomes. That is 2 is the base because head, tail. A coin has 2 faces, head, tail. So 2 is the base. The number of times will come in the number of times you toss it comes in the power. So once means here 2 times. Only 1 coin. So heads and tails. Base is always 2. If you toss it once, 2 to the power 1, 2 outcomes. If you toss 1 coin 2 times, so 4 outcomes. If you toss 1 coin 3 times, then 8 outcomes, and so on. So if you toss 1 coin 4 times, 16 outcomes. If you toss 1 coin, why 2 I'm writing because head, tail, 2 sides. The base will be 2. If you toss 1 coin 5 times, you'll have 32 outcomes. The sample space will have 32 outcomes. Yeah, now tell me, children, what's a sample space? When you toss a coin once, what is the sample space?
2, ma'am.
No, what is the sample space? Not how many outcomes. Okay, 2 outcomes. What are the elements in the sample space?
Head or tail?
Heads, tails. Okay, then next one, if you toss a coin 2 times or 2 coins once, how do you find the sample space? How do you find the sample space?
Ma'am, 2 heads. Then 1 head and 1 tail, 1 tail and 1 head, and 2 tails.
No, what did I tell you now? Write this 2 times. HT, write it 2 times, correct? Then after that?
Add H in the first row and T in the second row.
Yeah, H in the first row and T in the second row. Very good. So 4 outcomes. So 4 outcomes. Then 3 coins once or 1 coin 3 times. How do you write the sample space? What should you write 2 times? How will you find the outcomes when you toss a coin 3 times?
Ma'am, write all the outcomes before, ma'am. HH, TH, HT, TT, ma'am.
HH, HT, TH, TT. 1 minute. Sorry. HH, HT, TH, TT. How many times?
2 times, ma'am.
Okay, then?
Now add H to the first row and add T to the second row.
Correct. H to the first row, T to the second row. So you get 2 outcomes when you toss it once, you get 4 outcomes when you toss it twice, and 8 outcomes when you toss it 3 times. Because 2 to the power 1 is 2, 2 squared is 4, 2 cubed is 8. Okay, that's what is explained in the tree diagram here. Take a screenshot, children. Or you can take a screenshot from here. 1 second. Yeah, take a picture. Every slide, please take a picture today. I will not be repeating it. Every slide, please take a picture today. We are only discussing, we are not writing anything. Yeah. So you can understand this tree diagram. See here, I'll explain this for you. So heads and tails, this is ones, this is ones. Okay. Now, this is for 2 times, 2 times. So what should you do? Write H 2 times. See here, this is not there. This is not there. Okay, so write, if it is 2, if you toss it 2 times, write H 2 times, write tails 2 times. Then to the heads here, to this H, fix H and fix T. Then to the tails here, fix H and fix T. This one we write later. This we write later. Right. So 2 times means write heads 2 times and tails 2 times. Then we have heads here, right? Fix H and T. And here also fix H and T. HT, HT. HT, HT. So these are the outcomes. Now again, if it is 3 times, write this 2 times. HH, this one. Write it 2 times. Write this one also 2 times. HT, 2 times. Then this TH, 2 times. And TT, 2 times. Then fix HT, 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 HT. What I told you earlier is actually easier, but sometimes the teachers might do it like this for you. So I just thought I'll tell you. This is 4 coins. This is 4 coins, same thing. Write this here. Can you see H? This one, 2 times. H. Then this one, 2 times. HHT, HHT. HTH, HTT. So now you'll be writing only these 3. Fix H and T. This one you've written. Fix H and T. You've written this and this. Fix H and T. Similarly here. HTT. Fix H and T. Continue like that. So you can see here there are 2 outcomes, 4 outcomes. Here in all 18 outcomes. Here in all you have 16 outcomes. This is when you toss a coin once, 2 times, 3 times, and 4 times. So I think this will be easier for you to remember HT. Then write the same thing 2 times. You can write it in 1 row also. HT, just put it 2 times. HT, put it 2 times. That's all. HT, put it 2 times. Then HHTT. Then write this in 2 rows. HHTH. The order is not important. Any order. Then what is it? And to all this fix H. And to all this fix T. You can remember like this. That's what you see here. Take a picture. Yeah. Now we need to understand the meanings of these 2 terms, at least and at most. We need to understand the meanings of these 2 terms, at least and at most. At least and at most. At least, supposing I say at least 2. At least 2 means 2 or more than 2. When I say at most 2, that means 2 or less than 2. When we say at least 2, give me at least 2, that means 2 or more than 2. 2 or more than 2 is at least 2. At most 2 means 2 or less than 2. And when we say 2 or less than 2, it means 2, 1 and 0 also. At least 2 means 2 or more than 2. So at least 2 means 2 or more than 2. So 2, 3, 4, 5, 6 and so on. At most 2 means 2 or less than 2. So it can be 2, 1, 0 also. Okay. Yeah. You answer the questions? What's the probability? Yeah, what's the probability of getting 3 heads? Okay, so how many times can we get 3 heads? 23 times. So 23 upon the total, 200. 23 by 200 is the probability. Now, what do you see in the table there? 3 coins are tossed, 3 coins are tossed simultaneously 200 times. And 23 times 3 heads happen. 3 coins are tossed. 3 coins are tossed up simultaneously 200 times. So 23 times 3 heads happen. 84 times 2 heads. 71 times 1 head. And 22 times 3 tails. Now we understand 3 heads and 3 tails, understand. But 2 heads is confusing, no? How come we are tossing 3 coins, then 2 heads? That means 1 tail. This means 1 tail. It's understood that this is 2 heads meaning 2 heads and 1 tail. It's understood. 2 heads and 1 tail is understood. Because they're tossing 3 coins. So you will see 1 on each coin. But here the heading is 2 heads. 2 heads, okay. Then what about the third one? That is a tail. It's understood it's 1 tail. The third coin is showing a tail. 1 head. But 3 coins. So that means 2 tails. 1 head and 2 tails is understood. 3 tails. The 3 coins show tails. In the first one, the 3 coins show heads. So this is how we need to understand the table. And the frequency is given. How many times these outcomes happen? What are the outcomes? 3 heads, 3 tails, 2 heads and 1 tail, 1 head and 2 tails. These are the outcomes. And it's given how many times they happen. How many times the outcomes happen. So the first question is the probability of getting 3 heads. So 23 times out of 200 times is the probability. B, probability of getting no heads. No heads. No heads means all tails. No heads meaning all are tails. 3 heads. 3 heads means what? 0 tails. And 3 tails means 0 heads. Now tell me the probability, children, for getting no heads.
I'm 22 by 200.
22 by 200. And if it is possible to simplify, you must simplify. So it will be 11 by 100. You people tell me, I'll write. What do you mean by 3 heads?
No tail, ma'am.
No tails. No tail or 0 tails. Okay, then 2 heads means?
One
One
tail.
tail.
1 tail. 1 head means?
2 tail.
2 tails. And 3 tails means?
0 head.
0
0 heads.
No head.
No heads, correct. Yeah. Next one, no tails. Probability of getting no tails.
23 by 200.
No tails is equal to 23 by 200, correct. Then the last one, at most 2 heads.
84 by 200.
84 by 200.
20.
What do we mean by at most 2 heads? You want 2 heads, 1 head,
Or
or no heads? At most 2 heads means you want 2 heads or 1 head or no heads.
No, 129 by 200.
Tell me what all you should add.
Ma'am, 137 by 200.
2 heads. Where do you get 2 heads? How many outcomes? Sorry, what's the frequency for 2 heads?
84, ma'am.
84 plus
2 heads is 84. Then 1 head
71. 71.
and no heads.
22.
Ma'am, 177 by 200.
Yeah. So 177 by 200 is the probability. Because at most 2 heads means 2 heads, 1 head, no head. So you need to add all these frequencies, divide by, meaning the denominator is always 200. The denominator will always be 200. So 177 by 200. Somebody's mic is enabled. Please disable your mic. Tanya? Tanya, please disable your mic. Yeah, thank you. I'll just write this and then you take a screenshot, children. Yeah, take a picture now. You must write probability of getting 3 heads, of getting no heads, of getting no tails, of getting at most 2 heads. Done?
Yes, ma'am.
And wherever it is possible to simplify, you must simplify. 3 coins are tossed together. 3 coins. So now you have 3 coins with you. So you're tossing them together. You have 3 coins, so you're tossing them together only once. What are the outcomes, children? What will be the sample space? What are the outcomes? For 1 coin, it is HT. 2 coins, it will be HH, HT, TH, TT. So for 3 coins, write the same thing 2 times. HH, HT, TH, TT. Write it 2 times. HH, HT, TH, TT. Fix H. Tail. So we have 8 outcomes. Find the probability of getting exactly 2 heads. Exactly 2 heads. So and how many outcomes we have? Exactly 2 heads. 1, 2, 3, 3. Correct? In 3 outcomes, we have exactly 2 heads. So what's the probability?
3/8.
3/8 is the probability. Why 3/8? Because the total number of outcomes is 8. The total number of outcomes is 8. Out of these 8 outcomes, 1, 2, 3. 3 outcomes have exactly 2 heads. Exactly 2 heads. So 3/8. 3/8 is for the first one. At least 2 heads. At least 2 heads. That means 2 heads or more than 2 heads. So this one more than 2 heads, 2 heads, 2 heads. There's only 1 head, so this will not come. 2 heads. That's all. So how many outcomes? 1, 2,
4, ma'am.
3, 4.
4/8.
4/8 or 1/2. Third one. At most 2 heads. At most 2 heads means 2 heads, 1 head, no heads. 2 heads, 1 head, 2 heads, 1 head, 1 head, no heads. This one is no
3
heads.
by 8, ma'am. 3 by 4.
1, 2, 3, 4, 5, 6, 7/8. 7/8. At most 2 heads means 2 heads, 1 head, no heads. This one has 2 heads. This one has 2 heads, 1 head, 2 heads, 1 head, 1 head, no heads. So 7/8. Yes or no? Yes or no, children?
Yes, ma'am.
Yes, ma'am.
Okay. The last one. At least 1 head and 1 tail. See, this one we should read carefully. At
3
least
by
1
4.
head and only 1 tail. Okay, it is. It's not at least 1 tail. Only 1 tail should be there and at least 1 head. Yeah.
3 by 4, ma'am.
Sorry. Tell me the outcomes. In HHH. In the first one, HHH. Sorry. Will this be a favorable outcome? HHH?
No, ma'am.
No, because there's no tail. 1 tail should be there. Here,
Yes, ma'am.
Yeah, because it has at least one head and one tail. This one?
Yes, ma'am.
This one?
Yes, ma'am.
Yeah, at least one head. No, there is no, at least one head is here. And one tail. See, children, the question is at least one head. There is one head, at least one head is there. And one tail, yeah, there is one tail. There is one tail. See, if you see at a restaurant, you know, okay, how do I put this? Like this one, every outcome will have three things. Here, every outcome will have three things. In the specification, there's only two. What is at least one head and one tail? See here, does it satisfy the condition there? Yeah, there is at least one head here, and there is one tail here. So this is also a possible outcome, a favorable outcome. And here, at least one head, yeah, and one tail. Yes, this also is favorable. At least one head and one tail, favorable. At least one head and one tail, favorable. At least one head. No, here it is not there. At least one head is not here. So 6 by 8. 6 by 8, which is 3 by 4. Yeah, now tell me one by one. Somebody tell me the outcomes which are favorable for this one. Which are the outcomes favorable for the first one?
HTH.
For the first one.
HTH.
Okay.
THH.
Okay.
HHT.
Very good. For the second one?
HHH.
Okay.
HTH.
Okay.
THH.
Okay.
HHT.
Okay.
That's it, ma'am.
Correct. Okay. Yeah, you can take a picture. Okay. So this is how a deck of playing cards will look like. These are the different cards. These are the different cards in a pack of playing cards. Clubs, spade, heart, diamond. These are the four suits. These are the four suits. SUITS. These are the four suits. Club, spade, heart, diamond. Heart and diamond, as you can see, are red cards. Red cards. Heart and diamond, they're red cards. Spade and club, as you can see, are black cards. They are black cards. How many number cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 number cards are there. There are 9 number cards. One ace card. One ace card. One jack. One queen and one king. Every suit. You can see here there are 4 suits. There are 52 cards in all. A deck of playing cards will have 52 cards. a deck of playing cards will have 52 cards. 52 divided by 4, 13. There are 4 suits. Club, spade, these are black suits. Heart and diamond, red suits. 13 cards in each suit. 13 cards in each suit. And what are the 13 cards made up of? 9 number cards. 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 number cards. 1 ace card. And then 1 jack, 1 queen, and 1 king. Now you can see the face of the jack, the face of the queen, the face of the king. So king, queen, and jack are also called face cards or picture cards. They're called face cards or picture cards. Because you can see the picture of the king, queen, or jack on it. Ace, you can't see any picture. Pictures are only on 3 cards here, jack, queen, and king. So these cards, jack, king, and queen, they're called face cards or picture cards. Okay, so 13 cards are divided like this. 13 cards are divided like this. There is 1 ace card, 9 number cards, and 3 picture cards. 3 picture cards. Every suit has 13 cards. The 13 cards are 1 ace card, 9 number cards, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 number cards. 1 ace card, so totally 10. And 3 picture cards, king, queen, and jack. So each suit has 13 cards in all. 2 black suits, 2 red suits. The black suits are club, spade. Red suits, heart, diamond. Now tell me, children, in a particular suit, in one particular suit, how many number cards?
9.
How many ace cards?
1 ace.
How many picture cards?
3.
So in one suit, that is in one suit, meaning in 13 cards, there will be 1 ace card, 9 number cards, 1 number is not there, from 2 to 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 number cards and 3 picture cards. So totally 13. Now answer my question. How many number cards in black? How many
18.
number cards?
18, ma'am.
9 plus 9, 18. How many number cards in black? 9 plus 9, 18. How many picture cards of diamond?
3.
3. How many picture card of diamond means 3? Because diamond is one suit. Diamond is one suit. The 3 suits are spade with something
4
like.
suits.
Sorry?
4 suits, ma'am.
Oh, I made a mistake in saying that.
Yes, ma'am. You told 3.
Oh, okay. Yeah. So 2 black suits, spade and club. 2 red suits, heart and diamond. Okay. How many queen cards?
4, ma'am.
4 queen cards. How many black jacks?
2, ma'am.
2.
2. How many aces of red?
2, ma'am.
2. How many picture cards of red?
6, ma'am.
6.
6. Picture cards of red, 6. Okay, so if you should remember clearly for one suit, 1 ace card, 3 picture cards, king, queen, and jack, and 9 number cards. This is the ace card. This is the ace card. This is club, spade, heart, diamond, red, red. These two are black. So a deck of cards contain 52 cards, 26 red cards, 26 black cards. 4 suits, 13 cards each. In each suit, there is 1 ace, 1 king, 1 queen, 1 jack. Then these numbers 10, 9, 8, 7, 6, 5, 4, 3, 2. The kings, queens, and jacks are called face cards. Along with the ace, they're called honor cards. Along with the ace, they're called honor cards. Only these 3 are called the picture cards because you can see the picture of the jack, queen, and king. Okay. Yeah, take a picture. Yeah. Yeah, answer the questions, children. There are 2 conditions for the first one. It should be a black card and it should be a queen card. For the first one, 2 conditions. It should be a black card and it should be a queen card. So how many cards are there like that?
2.
2.
Because if they say black card, 13 plus 13, 26 black cards. It's not sufficient if it's a black card. It should be a queen card also. So that means only 2. Because there are only
26, ma'am.
Because there are only 2 black queens. Black cards are 26. 13 spade cards and 13 cards of clubs. 13 plus 13, 26 black cards. But it should also be a queen. That means it can be only these 2. The queen of clubs and the queen of spades. The queen of clubs and the queen of spades. Only these 2. Because see, black means all this will come. Black cards, everything. 13 plus 13, 26 black cards. But there's one more condition. It should be a black. It should be black and the queen. And the queen means only this and this. Only this and this. So 2. 2 by 56. Always the denominator will be 56. Oh, sorry, 52. What am I doing? Sorry. The denominator is always 52 because the total number of cards is 52. Because the total number of cards is 52. Which reduces to 1 by 26. Yeah, second one, children.
12 by 52.
12 by 52. A picture card. So picture card 3, 6, 9, 12 picture cards. Ace is not a picture card. Ace is not a picture card. There's no picture on ace. That's not a picture card. A picture card. So 12 by 52 simplifies to 2 6 2 26 times. Then 2 3 2 13 Correct?
Yes, ma'am.
Okay, next.
Ma'am,
A
C.
number card of red suit.
18/52.
1852.
Yeah. A number card of red suit. Number card. So these of red suit. These are number cards. These are also number cards of red suit. So if you count 18 cards are there. 18. It should be a number card of red suit. So 9 plus 9, 18. Yeah. The ace of clubs.
1/52.
Yeah. Ace of clubs means only this card. Ace of clubs. This is club and this is the ace of clubs. This is clubs. This is club, the club card. And this is only the ace of clubs. So 1/52. Fourth one is 1/52. It should not be a heart. It should not be a king. It should not be a heart. How many heart cards are there?
13 heart cards.
Yeah, 13 cards of hearts. Okay, 13 cards of hearts. It should not be a heart. It should not be a king also. How many kings are there?
4 kings.
But one king is already included in 13, right?
Yes, ma'am.
So remaining 3 kings. So neither a heart nor a king. Neither a heart means heart cards 13. It should not be a king also. 4 kings, but one king is already included in 13. So 3 more. So it should not be these 16 cards. It should not be these 16 cards. So it should not be a heart. It should not be a king. So 16 cards are there. 16 cards are hearts and, king. So subtract 52 minus 16. What's that? 36. 36 is the number of favorable outcomes. 36 is the number of favorable outcomes. So 36/52. 4 nines are. Sorry. Today I had to do so much of chores and I'm extremely tired. I'm yawning. I'm very sorry. Yeah. Yes, children. The 6th one. See, to tell you the 5th one again, it should not be a heart. That means 13 cards are gone. It should not be a king also. 4 kings, but 1 king is already included in 13. So the remaining 3 kings. So the 16 cards is not favorable because you don't want. If you want, it's favorable. If you don't want, it is not favorable. You don't want heart, you don't want king. So 16 cards you don't want. Then what do you want? 52 minus 16 you want. You must take the favorable outcomes in the numerator. The numerator must have the favorable outcomes. The denominator will have the total number of outcomes. So here the denominator is 52. The favorable number of outcomes is 52. Sorry, the total number of outcomes is 52. The total number of outcomes is 52. Favorable will be in the numerator. But you don't want these 16s. Then what do you want? You want 52 minus 16. You want this 36. So favorable is 36 out of 52. That's the probability for the 5th one. Favorable outcomes 36. Total 52. Probability is always favorable outcomes by total number of outcomes. So what you don't want, you should not write in the numerator. What you want, that should be in the numerator. Okay. Now, sixth one. You want either a black or a 10. You want it. You want is only favorable. What do you want? You want either a black card or a 10. So what
24.
is that you want? How many black cards?
26.
And how many 10s?
2.
2.
4.
There are actually 4 10s, but 2 10s are already included in this 26. So 2 more. So 28. You want these 28 cards. It's not that you don't want them. You want this. You want either a black or a 10. So you want these 28. So that's favorable by total. Simplify. 4 7s are 28, 4 13s are. This is for the sixth one. What do you want? You want a club or a jack? You want a club or a jack? How many club cards?
13.
And how many jacks?
2.
No.
3.
3 jacks. 3 jacks.
3.
Because club is only one suit. Club is only one suit. So you want clubs 13. In that 13, one jack is already there. Of the 4 jacks, 1 jack is there in 13. So remaining 3 jacks. 3 jacks. It can be clubs or a jack. You'll be happy with both. If you get clubs, happy. If you get a jack also, you're happy. You're happy with anything of these. Clubs 13, jack 3. You're happy with 16. So 16 is favorable by total 52. Yeah, I've not made the answer for this one. You can just take a picture of the slide. If all the number cards of spades, okay. Spades. If all the number cards of spades, how many number cards are there in spades?
9.
9. And the face, if all the number cards of spades and the face cards of black, how many face cards of black? How many face cards of black?
6.
6 are removed. Oh, so these 15 cards are removed. So 52 minus 15, only these are remaining. So the denominator will be this one, 37. The denominator will not be 52. The denominator will not be 52. 52 minus 15, 37, because you're removing these 15 cards. If all the number cards of spades and the face cards of black are removed from a pack of 52 cards, what is the probability that a card picked is a black card or a 7? What is the probability that it's a black card or a 7? Yeah. Now in spades, spade is a black card. In spades, how many cards remain?
1.
What is that one?
Yes.
Ace. Only the ace remains. Dileepan, why were you absent for the last class?
And there was a function.
But you didn't text me. You didn't ask me for the recording. You're not bothered if you miss a class.
Sorry, ma'am. I just think to ask to you at the end of the class.
No. End of last class you should have asked, not today's class. Or you can send a message, no?
Sorry, ma'am.
You didn't inform me also that you will not be coming. In fact, a few others also, Raghavi, Ritika, Rakshita informed me. Madhumita told me. Tanya also told me. Many of you missed the last class. Dileepan, Ritika and Raghavi did not mention. You just took a holiday by yourself. The others, yeah, did message me. Students who are absent for a class must text me the reason. If you know the reason beforehand, you should share the message with me. And at the end of the session, you should request for the recording.
Ma'am.
Yeah.
Ma'am, we had pre-midterm that day, ma'am. So like I was studying for that, so I can't attend class.
No, that I know. That reason now I know the reason. But you did not inform me. I came to know from your friends because Arjun had told me that he'll not come. So like that, I came to know the reason, but you did not tell me, no?
Sorry, ma'am.
And what about the class you miss? That's just gone off like that, huh? Meaning you don't want to know what happened that class?
No, ma'am. After like exams, I'll see that and I'll write the notes.
Okay. No, but recording you have to ask me, no? Where will you find the recording?
Ma'am, I'll ask you when the pre-midterm ends, ma'am. Like,
Oh,
I can't
okay.
see it.
Okay, okay. I'll let you know. Fine. So what is the probability that a card picked is a black card or a 7? Or a 7. So black card. So let's analyze the black cards. Spades we have and we have clubs. Okay. But remember that in spades, the 9 number cards are removed. They're not there. The 9 number cards are removed. And the face cards are also removed. Face cards of black are removed. 1 minute. Let me just write it for you. 1 second. It's not difficult to write. What is removed? Spades or the 9 number cards are removed. The 9 number cards are removed of spade. There are only 9 cards, 9 number cards. They're removed. And then what is removed? If all the number cards of spades and face cards of black, these are removed. So these are the cards that are removed. What is the probability that the card picked is a black card? So how many black cards are remaining? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 black cards are remaining. 11 black cards are remaining. Or a 7. Or a 7. So what should I add to this? To 11, what should I add?
2, ma'am.
2. Because 2 more. One, 7 of heart and 7 of diamond. Because the 7 of spade is gone. It's removed. And the 7 of club we already counted in 11. So 13. So 13 by 37 is the probability. 13 by 37. 13 by 37 is the probability. We'll see it again. See here, spade, club, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, so what's removed? All number cards of spades gone. All the number cards of spade gone. And all the face cards of black are also removed. Okay, so from 52, how many cards are removed? 9, 10, 11, 12, 13, 14, 15 cards are removed. They counted correctly? 1, 2. Correct, no?
Yes, ma'am.
So 37. So your probability, the denominator is 37. Your probability, the denominator is 37. Now, what is the probability that a card picked is a black card? So how many black cards are remaining? How many black cards are remaining? Here there are 9, 10, 11. 11 black cards are remaining. So this is favorable. You want a black card or you want a 7. How many 7s are there in all? 4. But 1 7 is not there. There's 1 7 is not there. Then this 7 is already counted here. When you counted 11, you have already counted this 7. So 2 more, 13. So 13 by 37 is the probability. Take a picture, children. The probability is 13 by 37. Probability that a card picked is a black card or a 7 is 13 by 37. Yeah. You know, when a die is rolled, these are the 6 outcomes. When a die is rolled, these are 6 outcomes. It can show 1, 2, 3, 4, 5, 6. When 2 dice are rolled, you can see here. This is the outcome on the first die. This is the outcome on the second die. Outcome on the first die, second die. First, second, first, second, first, second. When you roll 2 dice, there'll be in all 36 outcomes. Because as we saw earlier, number of outcomes is 6, like 1, 2, 3, 4, 5, 6. And in the power, you must write the number of, dice you're using. So 2 dice, so 6 square, 36. And with only 1 die, 6 outcomes. 3 dice, 216 outcomes, and so on. So look at the outcomes. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, and so on till 6, 6. You can see the outcomes along the diagonal. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. This is called a diagonal. This is the diagonal. And these outcomes are called the doublets. These outcomes are called the doublets. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. They're called the doublets. Now, along this diagonal, you can okay. So this diagonal divides all the outcomes into 2 portions. You can see some outcomes above the diagonal here. You can see some outcomes below the diagonal here. You can see some outcomes above the diagonal here and some outcomes below the diagonal here. You can see that above the diagonal, supposing you call the outcomes as A, B. Supposing you call the outcomes as A, B. You can see that above the diagonal, A is less than B. And below the diagonal, A is greater than B. Just watch out for that. Above the diagonal, everywhere the first number is less than the second number. Below the diagonal, the first number is greater than the second number. Along the diagonal, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 along the diagonal. Then we have outcomes above the diagonal, below the diagonal. Above the diagonal, you can see that the first number is always less than the second number. Below the diagonal, you can see that the first number is greater than the second number. Now, in all, there are 36 outcomes. 6 outcomes gone along the diagonal. 36 minus 6, 30. There are 15 outcomes above the diagonal, 15 outcomes below the diagonal. So here there are 15 outcomes. Here there are 15 outcomes. And along the diagonal, 6. 15 plus 15 is 30 plus 6, 36. Along the diagonal, there are 6 outcomes. Below the diagonal, there will be 15 outcomes. Above the diagonal, 15 outcomes. So like this, 36 outcomes. So the total of 36 outcomes, it can be divided into 3 parts. Okay, 36 can be divided into 3 parts. Okay, A is less than B, A is equal to B, A is more than B. A is equal to B, 6 outcomes. That is 1, 1, 2, 2, 3, 3. A is equal to B. The first outcome is A, the second outcome is B. A is equal to B in 6 outcomes. A is less than B in 15 outcomes. A is greater than B in 15 outcomes. So like this, we have 36 outcomes. So this is the region A is equal to B. 6 outcomes. This region A is greater than B. 15 outcomes. And this region A is less than B. 15 outcomes. 15 plus 15, 30 plus 6, 36. These outcomes are also called the doublets. Doublets. So what is the if you call this A and this one B? Now, one more thing is, how do you answer this question? What is the probability that A by B will be less than 1? A by B less than 1 is above here, no? Where is A by B less than 1? A by B less than 1 means what? It's a proper fraction. A by B is greater than 1, meaning improper fraction. A by B is less than 1, meaning it's a proper fraction. Here it's all a proper fractions. Here 1 by 2, 1 by 3, 1 by 4. A by B, 1 by 5. It's all proper. 1 by 6, 5 by 6, all proper fractions. So 15 by 36. A by B greater than 1. Improper fraction. Greater than 1. See, 3, 2 by 1, 2. More than 1 it is. 3 by 1, 4 by 1, 5 by 1, 6 by 1, 6 by 2, 5 by 2, 4 by 2. The numerator is greater than the denominator. A by B is greater than 1, meaning the numerator should be more than the denominator. So here they are, 15. And A by B is equal to 1 is 6 by 36. A by B is greater than 1 means the numerator should be bigger. Improper fraction. You can take a picture. So when a die is rolled, when a single die is rolled, 6 outcomes. when 2 dice are rolled, 36 outcomes. Or if a die is rolled 2 times, one die is rolled 2 times, then also 36 outcomes. Yeah. In how many places we have sum of 9? Sum 9, 3, 6, 4, 5. Sum 9. Correct? In all these places, we have sum 9. So how many favorable outcomes? 4. Totally 36. So 4 by 36 or 1 by 9. A sum 9. Should write like this. Probability of getting a sum of 9. Probability of getting a sum of 9 is equal to 4 by 36, or 4 is favorable. Total is 36, which is 1 by 9. Similarly, the probability of getting a doublet. How much is it? What is the probability of getting a doublet? 6 by 36 or 1 by 6. Correct. Yeah, you can try this one. Take a picture of this one. You can try this. We'll see the answers in the next class. A and B are friends. In the year 2020, what is the probability that both will have the same birthday, different birthdays? Are the probabilities the same as for the year 2019? 2020 is a leap year. Leap year meaning it has 366 days. 2020 is a leap year. That means it has 366 days. Now, these two friends, for these two friends, we'll have to find for the year 2020 the probability that they'll have the same birthday. So, how many outcomes, children? See, when I ask you how many outcomes, I mean like when we toss one coin 3 times, how many outcomes? 8 outcomes. If you roll 2 dice once, how many outcomes? 36 outcomes. So like that, in this situation, how many outcomes?
336.
Sorry?
336.
336, huh? 336 or 366?
Sorry, ma'am, 366.
Okay, the total number of outcomes is 366, is it? Okay. Now, remember, children, supposing now this in the case of the die, in the case of the die, we have like I think 1 second. Just imagine here See here, what do we have? What do we have here? 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. So totally 6 into 6, 36 outcomes. When you count, when you count, you'll have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So totally you have 36 outcomes. Now A and B are two friends. Okay. Now for the year 2020, for one friend, you must write out the days in the calendar. 1st January 2020, 2nd January 2020, 3rd January 2020. Like this, it goes on till 31st December 2020. Here also for the second friend, you must write 1st January 2020, 2nd January 2020, 3rd January 2020, so on till 31st December 2020. So that means you have 366 entries here and 366 entries here. Why should we write like this? Because both of them could have been born on 1st Jan, 1st Jan, or 1st Jan, 2nd Jan, 1st Jan, 3rd Jan, 1st Jan, 4th Jan, 1st Jan, 5th Jan, 1st Jan, 6th Jan. Like that goes on. It goes on till December. You'll have 366 entries here and 366 entries here. Because in one outcome, you should have for both of them. In one outcome, you should have for both of them. Like, see, now if I take the outcome here, this one will have 1st Jan, 2nd Jan, 3rd Jan, 4th Jan. This one will be 4th January and 1st January. And 1st January. So this is one combination. 4th January, 1st January. First friend, 4th January, second friend, 1st January. So when you look at this, the total number of outcomes should be 366 into 366. 366 into 366. So the total number of outcomes here is 366 into 366. So the number of days on which A and B will have the same birthday will be along the diagonal. Along the diagonal, same birthday. Like for the dice, we had 1, 1, 2, 2, 3, 3 along the diagonal. Equal entries we have along the diagonal. Similarly, here also they'll have the same birthday, like 1st Jan, 1st Jan, 2nd Jan, 2nd Jan, 3rd Jan, 3rd Jan, 4th Jan, 4th Jan, 5th Jan, 5th Jan, 6th Jan, 6th Jan. So like that, 30th January, 30th January. It go on then. 28th February, 28th February. Then like 31st July, 31st July. 30th November, 30th November. 31st December, 31st December. So along the diagonal, you'll have 366 entries. Along the diagonal, see, diagonal always will have equal entries. And it's always a square. Such a thing is always a square because you have 366 entries like this, 366 entries like this. So it's always a square. And along the diagonal, the entries will be equal. Along the diagonal, the entries will be equal. So same birthday will be 366. I did not count. Like you should use a smaller version to understand the bigger ones. You must use a smaller version to understand the bigger ones. Nobody can count it now, but you can imagine that it will be like that. Using this example, here there are 6 outcomes, meaning 6 numbers here, 1, 2, 3, 4, 5, 6. Here 6 we have. So totally 36 outcomes are there, 6 into 6. And you can see along the diagonal, same entries. So consider the same thing for 366. 366 this side, 366 this side. So total number of outcomes like 6 into 6, it will be 366 into 366. Total number of outcomes. And how many equal outcomes? Along the diagonal. Along the diagonal. So here you have 6 entries along the diagonal. So in this case, you will have 366 entries along the diagonal. For the die, you have 6 entries along the diagonal. For the leap year, we'll have 366 entries along the diagonal. So we are understanding a bigger model using a smaller model. So same birthday will be along the diagonal 366. So different birthdays will be the total, this one, minus 366. Minus 366. Total outcomes, this one. Same birthdays is this one. So different birthdays will be, you should subtract. So take out 366 common. How do you subtract? Take out 366 common. So you'll get 366 minus 1. So 366 into 365 outcomes, different birthdays. See, 366 into 366 minus 366. We are taking out 366 common. So for this bracket, the other 366 we should write minus. This one is common, so 1. So 366 into 365 outcomes, different birthdays. Different birthdays. Same birthdays, 366. Different is this one. So now the probability. Probability will be same, this one, by the total, this one. So 366 cancel, so 1 by 366. Different birthdays, this one, numerator, this one, denominator. Always total will be the denominator. This one is a numerator, this one is a denominator. So this gets cancelled. 365 by 366. Now the question is, will the probabilities be the same for the year 2019? 2019. No, in 2019 is not a leap year. So there'll be only 365 days. 365 days. So the probabilities will not be the same because the total number of outcomes, everything will vary. Because leap year has 366 days. So this will be the total number of outcomes. But a non-leap year will have only 365 days. So total outcomes will be 365 into 365. So the probabilities will not be the same. The probabilities, are the probabilities the same for 2019? No. Take a picture, children. All right, children. So I had texted you on WhatsApp that the class today is only till 9 o'clock. I hope all of you noticed that. Correct? Yeah. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Ma'am?
Thank you.
Yeah. Thank you, children.
Ma'am,
Thank you.
some days before you had given some case study based questions on